Another day, another story. Gravity plays a critical role in shaping Mercury's characteristics, dynamics, and its place in the solar system. Here's how gravity affects Mercury. Welcome to Tabo Eminent Channel. And Mercury's gravity. Mercury's surface gravity is about 3.7 m/2, which is 38% of Earth's gravity. This means it has a weaker gravitational pull compared to Earth due to its smaller mass and size. The weak gravity effects. Atmosphere. Mercury has a very tenuous atmosphere called an exosphere because its gravity isn't strong enough to retain a thick atmosphere against solar wind and thermal escape. Escape. Velocity. Objects require less energy to escape Mercury's gravity than Earth's, contributing to the loss of gases and particles into space. 2. Sun's gravity. Mercury is the closest planet to the Sun, so the Sun's gravitational influence on it is extremely strong. Orbital effects. Mercury's orbit is highly elliptical, eccentricity 0.206, meaning the Sun's gravity pulls more strongly when Mercury is closer, perihelion, than when it's farther away, aphelion. Precession of perihelion, Mercury's perihelion, the closest point in its orbit to the Sun, shifts over time due to gravitational interactions. This phenomenon was famously explained by Einstein's general theory of relativity. 3. Tidal forces. The Sun's gravity exerts tidal forces on Mercury, affecting its rotation. Mercury is in a 3.2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the Sun. This unique state is due to the interplay of Mercury's gravity and the Sun's tidal forces. 4. Internal gravity. Mercury's dense core, which makes up about 85% of its radius, generates its own gravitational field. This internal gravity influences the planet's overall structure, helping it maintain a roughly spherical shape despite its small size. 5. Interplanetary dynamics. Mercury's position and motion are influenced by gravitational interactions with other planets, especially Venus and the Sun. These gravitational forces contribute to slight perturbations in its orbit over time. Mercury's importance in understanding general relativity. Mercury's orbit was the first proof of Einstein's theory of general relativity, which describes gravity as curved space time. Einstein proposed that mass curves space-time, affecting the trajectories of objects traveling through it, leading to new equations for general relativity, tests of general relativity. Einstein identified 3 tests to confirm his theory. The bending of starlight during a solar eclipse, confirmed by Eddington in 1919 as the gravitational redshift, which was proven in 1954. The prediction of planetary orbits, particularly focusing on Mercury's peculiar orbit S. Mercury's orbit and Newtonian predictions. Newton's equations, established in 1713, accurately predicted the orbits of most planets, but failed to account for Mercury's precession, which was observed to be 43 arc-seconds per century more than predicted SS. The perihelion of Mercury, the point of closest approach to the Sun, was found to process over time, creating a spirograph-like pattern in its orbit. Hypotheses for Mercury's anomalies. Early hypotheses suggested that the Sun's shape, or an undiscovered planet, dubbed Vulcan, could explain the discrepancies in Mercury's orbit SS. However, attempts to confirm the existence of Vulcan were unsuccessful, leading to the conclusion that it did not exist. Einstein's resolution in 1915, Einstein's general relativity, provided a new framework that accounted for the additional precession of Mercury's perihelion. which was derived from his equations of curved space-time S. The extra term in Einstein's equations accounted for the 43 arc-seconds per century discrepancy, confirming the compatibility of his theory with observed data S. Broader implications of general relativity. General relativity has practical applications today, such as in the Global Positioning System, GPS, which relies on corrections for gravitational effects to provide accurate location data S. Without these corrections, GPS systems would be inaccurate by approximately 10 kilometers per day. A fragile grip on atmosphere. Mercury's gravity is like a delicate tether, too weak to hold on to the rich, layered atmosphere seen on larger planets like Earth or Venus. Instead, its thin exosphere, made up of particles like oxygen, sodium, and hydrogen, is constantly escaping into space, replenished by interactions with the solar wind and micrometeoroid impacts. Imagine a planet perpetually shedding a ghostly veil, its gravity unable to fully embrace the gases that try to linger. The sun's relentless tug, Mercury's story, wouldn't be complete without its complicated relationship with the sun. Orbiting at a blistering average distance of 57.9 million kilometers, the sun's gravity has the planet in a perpetual dance. Mercury speeds through its orbit at nearly 47 kilometers per second, the fastest of all the planets. This velocity is both a testament to the sun's gravitational dominance and Mercury's desperate attempt to escape being pulled inward. This closeness makes Mercury feel the full force of the sun's tides. Over billions of years, these gravitational forces have locked Mercury in a 3.2 spin-orbit resonance. Picture this. For every 2 orbits Mercury completes around the sun, it rotates exactly 3 times on its axis. This creates unique phenomena, like days that are longer than its years, with one mercurial day lasting 176 Earth days. The battle for perihelion, Mercury's orbit, is an ellipse, and it drifts slightly over time in a phenomenon known as the precession of perihelion. This precession baffled astronomers for centuries, until Einstein came along. His general theory of relativity revealed that Mercury's motion isn't just about classical gravity. It's also shaped by the curvature of space-time caused by the sun's immense mass. Mercury became a celestial proof of Einstein's groundbreaking ideas, cementing its place as a key player in our understanding of the universe. The inner world's struggle beneath Mercury's cratered surface lies a core that dominates the planet's mass, a colossal, iron-rich heart. This dense core likely contributes to Mercury's weak but detectable magnetic field, one of the planet's many surprises. The gravity generated by this core keeps Mercury's body intact, but it also reflects a story of a world that might once have been larger, stripped of its outer layers by a cataclysmic collision or relentless solar forces. A cosmic ballet with neighbors, Mercury's gravity doesn't just shape its own update, it also interacts with the gravitational pulls of Venus, Earth, and even Jupiter. These subtle influences tweak Mercury's orbit, ensuring that no single year is quite like the one before. It's as if Mercury is a dancer in a celestial ballet, responding to every tug and nudge with a graceful adjustment. Mercury's tale is one of endurance, of a small planet holding its own in the face of overwhelming forces. Its gravity might be modest, but it's enough to keep this tiny, sun-scorched world intact and full of mysteries that continue to inspire wonder. A world of contrasts, Mercury's story is one of contrasts. Light and dark, hot and cold, large and small. It's a world defined by extremes, shaped by the gravitational forces that both nurture and challenge it. In its scars, ancient craters, endless plains, we see the history of a planet that has endured the sun's relentless glare and cosmic collisions, emerging as a symbol of endurance in the face of overwhelming odds. In summary, gravity, from both Mercury itself and external sources like the sun, shapes its atmosphere, rotation, orbit, and even its role in confirming aspects of gravitational physics like Einstein's relativity. Thanks for watching. Request you to subscribe the channel.